For the board demonstration, these four switches here are the opcode and binary. These four switches here are the ALU input A. The switch on the right is the carry input. Switch on the very left does nothing. Right now the opcode is set to 0, which is the inverse A function, and the LEDs are working properly there. LED number 6 lit up right now is supposed to represent 0. That is a correct representation of the inverse. Moving on to addition of A and B with no carry input. Right now the B input is set to 2, so with A set to 0, we have an output of 2. Add 1, 3. Add 2, 5. Moving on to A plus B with carry input. Carry in is on, add 1, and then the same operation. For only opcode 6, Cin will have an effect on the output, as observed. For any other opcode, starting at 7, no indication. Now to 5, no change. 4, no change. 3, 2, 1, and finally 0. In order to demonstrate overflow, B is set to 2. If A is set to 1, we get 3. Set to 3, we get 6. Set to 6, then we get overflow, because the result now is of opposite sign, and that's an impossibility. For the subtract now, if we input -8 into the system, -8 minus 2 should be -10. We get a positive result, which indicates overflow. For the carry output bit to be working correctly, we need to have a final sum of 16. Therefore, when we input A plus B being 14 plus 16, we have an output of 0 with a carry output of 1 indicating 16. Next operation, shift right. Right now, the most significant bit of A is being shifted to the right by 2 to the 2 position. The next significant bit on, that indicates correct, and then these bits have no effect on the output. Next function, arithmetic shift right, will work the same except as the last case, with the exception that the most significant bit will always remain on no matter what the input is, and that is observed. Next function, arithmetic shift left, or no, this function is actually just binary shift left. One position gets shifted left 2 for the B input of 2. Next input, and then the last 2 bits have no effect on the output. And finally, arithmetic shift left. For our example, it will work exactly like binary shift left. And that is all 8 opcodes.